Question 10 is really similar to question 9. The only difference is instead of having a horizontal asymptote, it has an oblique one. So our steps are still the same. We want to find the domain, and that's pretty easy on this one. Right? X cannot equal -1. Let's factor it and see if it reduces, though. So f reduced, go put that RED is standard for reduced. So f of x reduced equals, the top factors to be what? X plus 4 and x minus 1, right? Times them, get -4, add them to get 3. Okay, so we want to find anywhere it has a vertical asymptote. Well, the x plus 1 does not reduce. Nothing reduces. So since the x plus 1 stays, that means there's a vertical asymptote at x equals -1. So that's going to be number 1. Vertical asymptote at x equals -1. The oblique asymptote, let's get to that in just a second. Let's do the x-intercepts first, right, where it crosses the x-axis. So that we just did that, but we say to find that, we put 0 in for y. So x plus 4 times x minus 1 over x plus 1. Okay, just think about this. If I have a fraction equal to 0, that only happens if the top equals 0. So what would make x plus 4 equal to 0? That'd be at -4. And what would make x minus 1 equal to 0? +1. So I've got my vertical asymptote. I've got number 3. And then I just need to find the oblique asymptote. So the way we do that is you just, first of all, we know there's an oblique because the degree of the top is 2 and the degree of the bottom is 1. Whenever the top is 1 more than the bottom, it automatically means an oblique asymptote. And we can either do long division with this one, or we could do synthetic because it's just x plus 1. So I don't care how you do it. I just wrote it with long division. I'm not sure why, so I'm going to do it that way. What do I times x by to get x squared? Multiply it through. Got to subtract them. So this is actually going to change to a minus right there. That would be 2x minus 4. What? Times it by 2 to get x by 2 to get 2x. So that would be 2. Subtract them. Now remember, -1 was not a -1 was not a 0. So x plus 1 doesn't go into it evenly. We already know that. So it's okay that there's a remainder down here. It comes out to be -6. We ignore the remainder with oblique asymptotes. We just look at this. So there's an oblique or a slant asymptote at y equals x plus 2. And again, we don't have to worry about the remainder. Okay, that should be all we need. So we're going to take all that information. We got x equals -1. We got -4 and 1 for the x-intercepts, and then we got y equals x plus 2 for the oblique one. So let's see if we can graph that and make it work. I kind of wish they'd just let us like enter these in. It's kind of silly to graph it where we're not drawing the rest of it, but oh well. So again, a vertical asymptote at x equals -1. So I come over to -1, put 1 there, put 1 there. Okay, there's my vertical asymptote. Then I have an oblique one at y equals, was it x plus 2? So it crosses at 2. And if it's x, it means my slope is 1x. Just to kind of call on some of your prior math knowledge. I should give it to you right there. A point. Where does it cross the x-axis at? It crosses at, or my 2 points, -4 and -1. Nope, +1, sorry. Okay, let's see how that works for us. Looks good. So again, kind of weird. You don't draw the actual graph itself. You're just looking at you're just drawing the asymptotes and the x-intercepts just so you can see them there.